Have you ever wondered if a computer could think like us? Better yet, brainstorm like us? What if I told you that the latest advancements in artificial intelligence are bringing us closer to that reality than ever before? In today's video, we're diving deep into a groundbreaking approach called Tree of Thought prompting. It's a technique that enables an AI to brainstorm, plan, and strategize, quite similar to the way that we humans do. And the best part? It's opening up a whole new world of possibilities and solutions for complex problems. Firstly, we'll explain why we need Tree of Thought prompting, how it differs from the prompting techniques like chain of thought, self-consistency, and react, and how it works, and what problems it's ideally suited for. We'll conclude by showing how it can tackle extremely complex problems like portfolio optimization in capital markets to maximize risk-adjusted return and gene editing in life sciences. Hello, I'm Richard Walker from Lucidate, and today we're embarking on a journey that will redefine your understanding of AI. To understand the beauty of the Tree of Thought prompting, we must first take a step back and look at the existing AI models, more specifically language models like GPT-4. These models have traditionally been guided by input-output prompting, where the model is fed an input and then it generates an output. Quite linear, right? Well, researchers have experimented with methods like chain of thought prompting and self-consistency, trying to encourage more sophisticated responses. Chain of thought, or CoT prompting, helps the AI model think in a sequence of ideas, while self-consistency has the model debate with itself until it settles on a maximum voted for answer. But there are limits. Although they can help to solve problems, these methods often struggle with more complex tasks. This is where an exciting new method, Tree of Thought prompting, comes into play. So, what exactly is Tree of Thought prompting? Well, as I said earlier, it's a bit like brainstorming for an AI model. It's a method of generating several lines of thought similar to a decision tree, but more advanced. The model generates a series of thoughts or ideas which branch out into more thoughts, creating a tree-like structure of ideas, hence the name Tree of Thought. The AI model doesn't just follow a linear path from A to B. Instead, it explores multiple paths simultaneously, evaluating each one and keeping the most promising options. This dynamic way of problem solving opens up new possibilities for the AI. The evaluation of each thought is very similar to the way that early AI chess programs worked. The AI might generate several different thoughts, i.e. potential moves, each representing a different possible line of play. It would then assign a scalar value to each thought based on the predicted outcome of that line. After generating these scalar values, the AI would then use them to decide which thoughts to keep, they're the promising lines of play to explore further, and which to prune, unpromising lines of play that result in a checkmate. Without pruning, you will end up with an exponentially growing number of outcomes to evaluate. This becomes problematic, but if you are able to prune the tree and discard unpromising lines of thought, the identification of the optimum decision becomes easier. The developers of Tree of Thought prompting validated its efficacy against other prompting techniques. To do this, they used the deceptively simple Game of 24. The Game of 24 is a popular mathematics card game where 4 numbers are given, and the goal is to manipulate these 4 numbers using any of the 4 basic arithmetic operations, addition, subtraction, multiplication, and division, to reach the number 24. Each of the numbers must be used exactly once, and it's allowed to use parentheses to alter the sequence of operations. Here's an example. If you're given the numbers 1, 2, 3, and 7, you can reach 24 by 7 multiplied by 3 plus 2 plus 1 equals 24. Generative AI can find this challenging for a few reasons. Firstly, exponential search space. There are many potential combinations and permutations of the 4 numbers and the 4 operations. This creates a very large search space. 2. Inherent randomness. The numbers provided can vary, and sometimes it may not be possible to reach 24 at all. 3. Discrete and non-differential nature of the problem. Most AI techniques, particularly deep learning methods, work best with continuous and differentiable functions, where small changes in the input also result in small changes in the output. The game of 24 is a discrete problem. A very small input change can lead to a huge change in the output. This makes the problem harder for methods like gradient descent, which rely on these properties. 4. Need for explicit reasoning. The game of 24 often requires explicit mathematical reasoning, understanding of arithmetic, operation precedence, and sometimes the use of mathematical tricks. While AI has made strides in many areas, explicit reasoning remains a challenging one. This is an ideal test for an approach like Tree of Thoughts. There are multiple ways to approach this. Some may be more promising than others, and the algorithm can reject the less promising lines and pursue more optimal ones. Here you can see the results comparing the success rate of Tree of Thoughts against other prompting techniques on the game of 24. No contest. Portfolio managers face a problem very similar to the game of 24. They need to balance a mix of assets to achieve the highest possible return at an acceptable level of risk. This is known as portfolio optimization. Just as players must work with numbers and operations to hit the target in the game of 24, portfolio managers must juggle countless assets, each with its own return, risk, and correlation with other assets. They must optimize their portfolio to achieve the best possible return given their risk tolerance. This optimal mix of assets is found on what's known as the efficient frontier, a concept from modern portfolio theory. The efficient frontier represents portfolios that provide the maximum possible return for a given level of risk. Each point on this curve represents an optimal portfolio. According to the Capital Asset Pricing Model, or CAPM, the expected return on an investment is determined by its systemic risk, represented by the beta coefficient. The CAPM helps in determining the expected return of a portfolio. The portfolio optimization problem is like an advanced version of Game of 24. Instead of 4 numbers and simple arithmetic operations, we have multiple assets and complex mathematical models, but the concept of balancing different elements to reach a goal remains the same. Applying our Tree of Thought strategy can be beneficial here. A portfolio manager, much like Tree of Thoughts, starts with an understanding of the objective, which is maximizing returns for a given level of risk. Then they explore the various combinations of assets, their expected returns, risks, and correlations. After evaluating these combinations, they select the one that aligns best with their goal. By following this strategy, a portfolio manager can effectively optimize their portfolio, much like how the Tree of Thought strategy dominated the game of 24. Indeed, the complexities of the real world make these problems more challenging, but the fundamentals of problem solving remain surprisingly consistent. Similarly, in the field of life sciences, the problem of gene editing and drug design can be compared to the game of 24. When designing drugs, researchers work with various combinations of molecules to achieve a desired effect, such as inhibiting a particular protein or triggering a specific response in the body. This process requires a careful balancing act to find the right combination of molecules, similar to how the game of 24 requires the right combination of numbers and operations to reach the target. Thus, the combination of large language models and multiple prompt techniques, Chain of Thought, Self-Consistency, React, and here Tree of Thoughts, shows great promise in assisting professionals in capital markets, life sciences, and other disciplines to solve previously challenging problems. To wrap things up, folks, the Tree of Thought prompting strategy is revolutionizing the way we harness the potential of AI. By steering clear from traditional methods and enabling the exploration and evaluation of multiple solutions, Tree of Thought is taking us a leap ahead in problem solving. In industries like finance and biotech, or wherever complex problems require an in-depth exploration of solutions, Tree of Thought holds tremendous promise. I'm Richard Walker from Lucidate, and it's been my pleasure to guide you through this exciting new development in AI. If you found this video helpful, do give it a thumbs up and leave your thoughts in the comments section. It's always great to hear your perspectives, and I do my best to respond to as many as I can. Are there any complex problems you face in your work right now that you think Tree of Thought could solve? Again, leave a comment below. Remember to share this video with your colleagues, friends, or anyone who could benefit from this knowledge. And if you haven't already, hit that subscribe button and join our community for more insights into the world of AI. Want to take it a step further? Join us as a member to enjoy exclusive benefits like early access to new content, member-only videos, and much more. Let's explore the future of AI together. Thanks for watching, and see you in the next video.